Take a tour of your celestial neighborhood, the solar system. Visit your cousins on Mars, for you may be related to Martian life. A quick jaunt to the outer edge. Take a ride on Pluto Express and find out whether Pluto is really a planet. Want to strike it rich? Go to a near-Earth asteroid and see a mining colony of the future. And how about a little vacation at an amusement park on the moon? It's your neighborhood solar system, next on Discover Magazine.
Even though I realize that this is, in some measure, an act of faith and vision. But if I were to say, my fellow citizens, that we shall send to the moon...
In 1961, John F. Kennedy proposed an act of faith and vision and detailed plans.
More than 300 feet tall, capable of standing heat and stresses, several times more than have ever been experienced.
At the time, this first bold step off our planet sounded like science fiction.
And then return it safely to Earth, re-entering the
Now, scientists are debating another bold step, space colonization. And they too have faith and vision and detailed plans.
And do all this and do it right, and do it first. Before this decade is out, then we must be bold.
If we want to settle the solar system, where should we go next? And how will we do it? Bob Zubrin has one vision: Mars.
We actually have the technology right now to send humans to Mars. I mean, we don't have all the hardware. We have to go and build some things. But we are vastly better positioned to send humans to Mars within 10 years right now than people were to send people to the moon in 1961 when John F. Kennedy made his speech. People then could have wrung their hands about how little they knew, and they knew very little. But they went and they learned it on the way, and they did it. And that's the way to get to Mars. If we're going to come up with good plans on how humans can explore Mars, you need to take a look first as to how humans have successfully explored the Earth.
One famous historical challenge was the Arctic's Northwest Passage. In the 19th century, the British Navy tried to bully their way through with huge warships. Their bloated missions failed, but one man with only dog sleds and hunting rifles succeeded.
The first person to successfully do the Northwest Passage was Amundsen, because what Amundsen knew was that the Arctic was rich in caribou, and if you knew how to use that resource, you could go into the Arctic and live off the land and actually carry off the Northwest Passage, which is exactly what he did on a shoestring budget when before him 100 expeditions with vast resources behind them had been failed. So if we're going to go to Mars, we want to take that lesson, which is travel light and live off the land. It's the only way to do things cheaply in exploration. It's the only way to do things effectively.
Bob Zubrin has a plan for living off the land. Mars has all the necessary elements: water and nitrogen to grow crops, iron and silicon for manufacturing. And with a simple chemical process, oxygen can be extracted from the unbreathable carbon dioxide atmosphere. He even has a plan for warming the planet from its now icy 81 below Fahrenheit or 63 below Celsius. He envisions colonists building huge factories to pump chlorofluorocarbons, or CFCs, one of the gases that causes global warming on Earth.
If we were to warm the planet by introducing CFC gases on a large scale, you could raise the planet a few degrees, which would cause a lot of CO2 to outcast from the soil, which would raise the planet's temperature still more. But it'd be a CO2 atmosphere. Humans couldn't breathe it, but plants could. And we could introduce plants to Mars, and they could spread across the planet and eventually oxygenate the atmosphere, although that would take thousands of years. But what we could actually do, though, is bring a dead planet to life. But if we do our job and the succeeding generations do their job, the day will come when people will lie down on those red sandy beaches of Mars, on the shores of the Martian lakes, surrounded by Martian ferns and palms, and it'll be a great place to live.
It's easy to make Mars sound like a veritable oasis compared to the moon. However, you've got to remember that you still need a spacesuit to go on Mars. You still have to worry about life support.
Mendel has a different vision, the moon. He believes we need to settle the solar system one small step at a time.
The moon is much more accessible, both in a scheduling sense, a technology sense, propulsion sense, life support sense. And that's really why I talk about the moon, because it is the place where we will cut our teeth on living in space. It's the kindergarten where we will learn how to settle the solar system.
The moon is a world much closer to home, only 5 days away instead of the 6 months it takes to get to Mars. Being so close, NASA will easily be able to test and refine new technology, everything from spacesuits to advanced life support systems that will recycle air, water, and human waste. Like on Mars, the astronauts will need to live off the land. Already there are plans to grow crops and to manufacture bricks and glass from lunar material. Mendel's team has even found a way to mine the moon's soil for oxygen.
Well, in this lab, we're trying to look at some very basic technology to extract solar wind gases from the lunar soil and analyze which ones are there. We've since discovered by doing experiments on real lunar samples that the hot hydrogen in a reactor will actually extract oxygen from any kind of iron-rich lunar minerals.
They may be able to produce oxygen, but unfortunately, the soil is practically barren of many other elements needed for life. The moon may not have what it takes to support a colony.
The moon is so dry that if there was concrete on the moon, lunar colonists would mine it to get the water out. The moon is so short in carbon and nitrogen, which are key elements of life, that on the moon, human excrement would be more valuable than gold.
The moon represents a place where we can get out and do it now and then go to Mars.
And yet there's another vision for settling the solar system, a place even easier to get to than the moon.
We think that the moon, the moon is so close, it's very, very easy to get out to the moon and back. It's only a week round trip. But the problem is that the moon has such a substantial gravity field that you pay a large amount of penalty. So the moon's not ideal. But it turns out that there are huge numbers of bodies that are actually easier to get to than the moon. It requires less fuel to get there and less fuel, in fact, sometimes incredibly less fuel to get back.
So what are these objects with less gravity and thus easier to get to than the moon? Near-Earth asteroids. Over 500 of these large rocky bodies swing by every year. But why bother? Let's examine a typical mile-wide asteroid called Ammon.
Well, it contains several trillion, not billion, several trillion dollars worth of iron, and several trillion dollars worth of nickel, and several trillion dollars worth of cobalt, and about 15 to 20 trillion dollars worth of rare and precious metals. This is one little metallic asteroid that's in an Earth-crossing orbit. If we don't use this one up, if we don't use it as a resource, then the odds are about 50-50 that it will hit Earth. If it did, then it would cause an impact that is perhaps 1,000 times more catastrophic than World War III. And yet, if we have access to it, if we have the space technology to get to it, then it suddenly turns into an incredible asset. It's worth approximately 10 times the gross national product of the United States.
If Fort Knox was on the surface of the moon and the gold was free for taking, it would be too expensive right now to go to the moon and bring back the gold and sell it. You would lose your shirt.
But we know right now how to lower launch costs by at least a factor of 10. That could be done immediately using new technology rockets.
These new rockets may one day bring down the cost of space travel. Right now, launching chemical rockets costs far too much to justify space mining. But at NASA's Jet Propulsion Laboratory, they're looking at the rockets of the future.
We believe that there are three keys to really opening up the solar system to human exploration and exploitation. And those three keys are propulsion, propulsion, and propulsion. In this chamber, we have a very high-powered lithium plasma engine that we're currently developing jointly with the Russians. This is an advanced plasma engine that runs on an inert gas called xenon. The blue glow that you see there is characteristic of the xenon exhaust. The farthest out, the most wildest sounding propulsion system that we're working on is an antimatter-based propulsion system.
There's also a less exotic alternative. In space, one could travel by an old-fashioned steam engine. All it needs is water and the heat of the sun to turn the water into steam.
The best source of propellants in space, believe it or not, is water. That means that our first question ought to be, where should we go from Earth to find the most accessible water? And the answer to me is unequivocal. It has to be a near-Earth asteroid, preferably one of those which are former comets, and they're mostly made of ice, 60% ice or thereabouts.
If propulsion costs do come down, our first settlements in space might very well be mining colonies. Where will we settle the solar system? Mars? The Moon? A near-Earth asteroid? It's not just a theoretical question, for someday we will have to go somewhere, whether to avoid a plague, an incoming asteroid, or perhaps even to avoid another colonizer.
In the long run, it's a question of survival. There's millions and billions of stars out there, and no doubt many of them have intelligent life evolving towards spacefaring capabilities, or perhaps already have them. If we remain a static culture, sooner or later we're going to be discovered, and we'll probably suffer the fate that most discovered peoples suffer, which is to be overrun by the more dynamic civilization that discovers them. I think the only choice is to grow or die.
Something's brewing in outer space, a debate that threatens to divide the scientific community. It's not the origin of the universe, and it's not life on Mars. No, it's whether cold, dark Pluto is really a planet.
Pluto is an exceptionally large comet. To say that the solar system has 9 planets is a grossly misleading statement.
Well, that's nonsense. It's 27 times bigger than the largest asteroid. Some of these people want to make feel important by making a big noise, and he did. It really caused enormous consternation.
I do want to stress that I meant no disrespect to Clyde Tombaugh. I think he's a fine man, and he did a fine piece of work in 1930. I think if I had been running the show then, it would have been different.
In 1930, things were different. Pluto only existed in the imagination of a few astronomers who thought there might be one more planet. It was also the beginning of the Depression. Clyde Tombaugh, a frustrated Kansas farm boy, turned his sights toward the stars.
My future at that time looked pretty dim. I was wondering what I would do for a living. I didn't want to farm. I didn't have any college education, so I couldn't do that. And I was really a really frustrated young man. But one thing I learned at home, all those nights at home, I learned how to use a telescope and how to find objects in the sky. You don't do that by going to a bar and drinking beer.
Clyde Tombaugh built himself telescopes and looked to the sky. Still in his yard today, his telescopes were constructed from the farm's junk pile. A cream separator, tin cans, even a shaft from a 1920 Buick. Clyde made drawings of Mars and sent them to the Lowell Observatory in Flagstaff, Arizona. He got back a job offer to search for a new planet and arrived without enough money for a return ticket. Tombaugh photographed the sky and analyzed his images with a machine called a blink comparator, which enabled him to shift back and forth between images of the same region taken at different times. Over short periods of time, faraway stars stay in the same position. A planet, because it is closer, will move.
It was pretty tedious. I spent 7,000 hours looking through the eyepiece of that comparator over 14 years, and that's a pretty tedious job. And during that time, I saw individually 90 million star images. So every one of them. 90 million is a lot, too.
In 1930, Tombaugh found the 9th planet. And what did it look like?
Just a little dot. Just like little dim little dot. It shifted position. That was a telltale. And then everything went wild. Everybody loved the farm boy finds a planet, you know.
65 years later, the Lowell Observatory still aims its telescope at tiny Pluto. In fact, the planet is so small, only 1,500 miles across, and so far away, 4 billion miles, that even today, seeing it is difficult. Following in Tombaugh's footsteps is Mark Bowie.
The first thing I need to do to find Pluto is to issue the command to the telescope that says, move the telescope to where Pluto is right now.
Clyde Tombaugh saw only a dim little dot. Today, with his powerful telescope, Mark Bowie sees only a dim little dot. Even with the very best telescope in the world, the Hubble, all we see of tiny, distant Pluto is a little dot. And yet, we're beginning to get a picture. We now know it has a moon, Charon, and that instead of orbiting Pluto, the two revolve around each other like a double planet. We know it has seasons, an atmosphere, and because it's so far away from the Sun, a 250-year orbit, but we've only scratched the surface.
There's a very good chance that I could end up looking at Pluto until my dying days. There's so much to learn, so much to understand, and it's not even the work of a lifetime to understand Pluto. Don't forget that it was only discovered in 1930. It's a 250-year orbit that transcends a normal human lifetime.
Mark Bowie is trying to understand Pluto's mysterious surface.
I have here a model of Pluto. On the bottom is rocks and dirt, and that's what we think makes up the interior. What I have here in this container is ground up charcoal. I use that because it's rich in carbon, and that's one of the things that we think is on the surface of Pluto.
Based on brightness studies, Mark Bowie thinks that Pluto's surface has two main components, fresh white frost and dark dirty frost. The only way to get a better picture of Pluto is to go there. NASA is planning just that.
Pluto Express is a very difficult mission. We're going to the farthest planet from the Sun. It's colder than anywhere else in the solar system out there, and we're doing it on a budget. On top here we have the stellar compass. This is what looks at the field of stars in the sky, just like we see from the Earth, and it allows the spacecraft to know which way it's pointed, which is very important because the cameras have to be pointed at Pluto when we're going by. And this package of instrumentation is the reason we're going. It's got a visible camera in it, kind of like a television camera. It's got an infrared imaging spectrometer, which measures the surface composition to considerable detail. It's got an ultraviolet spectrometer to look at the atmosphere. This is the so-called dropsonde or Russian probe that the Russian Space Agency is considering having carried aboard the Pluto Express science craft to be dropped into the atmosphere of Pluto as we approach. This is our communications link with the Earth, the radio gear, the transponder that communicates back and forth to Earth. When we arrive at Pluto, no matter how good a job we've done of the technology, we'll be arriving with 12-year-old technology for the hardware. But the software we can send up to the spacecraft throughout the entire mission. That'll be technology which people haven't even dreamed of yet.
The plan is to send 2 spacecraft, one to image each side of Pluto. They won't orbit the planet, but instead will do a flyby, giving a mere 2 hours to collect the best images. The crafts may also release a small probe to sample the atmosphere and image the surface. Pluto Express is scheduled to launch in 2001. When it actually arrives depends on the size of the launch rocket.
Yeah, there are probably a dozen different ways to get to Pluto with the launch vehicles that are available over the next decade. And each of those ways of getting to Pluto comes with a flight time and a price tag. And the thing that's most important in today's environment is the price tag.
A large Titan rocket could get the spacecraft directly to Pluto. It will take 6 years at a cost of $250 million. A smaller rocket could cost as little as $65 million, but will require up to a 12-year circuitous journey.
The present plan to go to Pluto has us leaving Earth early the next decade and then flying by Venus 3 times and then Jupiter once and then on to Pluto, and that's about a 12-year trip time. So each one of these swing-bys is giving us the kick to get to the next swing-by. It's sort of a daisy chain thing that allows us to use the gravity, which is free, in place of the bigger launch vehicle, which is not free. When we first talked about the mission, I was 36. And when we arrive at Pluto, I'll be 55. So I guess that'll be a good note on which to retire.
Regardless of when we get there, the view of Clyde Tombaugh's planet will be dramatic. But will we find anything beyond Pluto? Jane Liu is a modern-day Clyde Tombaugh, searching for objects at the edge of our solar system. Though she uses a computer and a modern telescope, her technique is the same as Tombaugh's. She takes images of the same region over time and looks for the moving object.
There are 4 images being displayed very rapidly here, so you can see them sort of blinking a bit. And you see lots of dots moving around. Those are just cosmic rays going through space, so we totally ignore them.
But today's telescopes are so powerful they pick up cosmic noise. Everything looks like a potential planet.
Basically, you try to program your brain to block them out. Because if you pay attention to every single blinking cosmic ray, you just go crazy.
Jane Liu spent 5 years searching through the cosmic noise without any luck. Then she found it, billions of miles away and only 125 miles across.
And now I put my cursor underneath a Kuiper Belt object, and you can see a faint little dot moving from right to left, right above my cursor. That's a Kuiper Belt object.
But what Liu found is too small to be a planet, so what is it? The planets accumulated from the collisions of small bodies. It has been theorized by Gerard Kuiper that the leftover small bodies, the remnants of planetary formation, lie in a belt at the edge of the solar system. Jane Liu found the very first of these Kuiper Belt objects and has since found 27 more.
Until we find these things, it was thought that Pluto was the effective boundary of the solar system. There was nothing beyond it. And then we found these objects, the Kuiper Belt. Most of the objects we have found are further than Pluto. They are the most distant solar system objects known to date.
Liu's discovery raises a new question. What is Pluto? A small planet or a large Kuiper object?
Very interesting object, and it's got a lot of companions, members of the Kuiper Belt, and it's the king of the Kuiper Belt.
Brian Marsden is the king of small celestial objects for the International Astronomical Union. When Jane Liu made her discovery, she went to Marsden for confirmation. If Tombaugh discovered Pluto today, he too would go to Marsden.
Okay, we have Neptune here on the inner track and Pluto on the outer track. The outer track being half as long again as the inner track.
Pluto is not only far smaller than any other planet, it's the only one to have this strange elliptical orbit. It even crosses Neptune's path. Marsden has found that many of the Kuiper objects share Pluto's strange orbit.
We realized that there were a number of other objects, just like Pluto, going around the Sun in periods half as long again. That just made it all click into position.
made it quite clear that one had to regard Pluto as the king of the Kuiper Belt, and it's therefore rather misleading to speak of it as the 9th major planet.
Now it seems that it's probably best to think of Pluto as the biggest Kuiper Belt object known. It's certainly a Kuiper Belt object. We found several other objects with very, very similar orbital characteristics. So basically they're almost identical to Pluto. The only difference between them and Pluto is the size.
If I told you that Pluto's got seasons, it's got an atmosphere that comes and goes with the seasons. It has a complicated surface, it's round. All of those things are things that you would associate with a planet, and you wouldn't be surprised about them at all. But an asteroid, it doesn't have those properties. An asteroid is a small, lumpy chunk of rock and bears very little resemblance to Pluto. There might be things out there we've mislabeled, but Pluto's not one of them.
Pluto, frankly, doesn't care what we call it. To me, it doesn't really matter so much whether it's a planet or not. I happen to think it is. Clyde Tombaugh thinks it is. The International Nomenclature Committee of the Astronomical Union thinks it is, and NASA thinks it is. That's good enough for me. But whether we call Pluto a planet or not, it is this enigmatic body at the edge of our solar system that has recorded events since before the Earth formed.
Only the International Astronomical Union has the authority to change the name or the status. And they aren't going to change the name of it.
In 1969, we landed man on the moon. It was the crowning achievement of American engineering and ingenuity. We left behind flags and footprints. We created heroes and memories. But today, the moon is empty. For after planting the flag only 6 times, we abandoned it. With fellow Apollo 17 astronaut Gene Cernan, Jack Schmitt was the last man to ever walk on the moon.
The first time I think any of us had a chance to really think about that Apollo 17 was the last mission to the moon was after we had gotten back into orbit and had a little bit of time in our rest periods to just think about what we had done. And unfortunately, there was the last time that any human beings would have a chance to work on the moon. That was enough, I think, to make anybody deeply involved in the Apollo program or in space or presumably in the history of humankind very, very sad. And it certainly made me sad, and I think the rest of the crew as well.
Why did we abandon the moon? Why did we go there in the first place? In 1957, a Soviet weapons expert realized that his new missile, designed to deliver a nuclear warhead, could also be used to launch a satellite. So the Soviets tried it and launched the space race. America feared it was losing its technological edge, a fear only heightened when the Soviets launched a dog, then a man, into space. So to prove its technical superiority, America challenged the Soviets to a race to the moon. How close was that race? Who better to tell us than a Soviet rocket designer who also happens to be the son of the former premier, Nikita Khrushchev.
I was close to my father because the dream of my father was to be the engineer. He was very proud that I am an engineer. And because I was in this business, we spoke with him very often. He asked me questions about Americans, about what we are doing.
To get to the moon, both sides would have to start from scratch to design a new, larger rocket. But this time, the Soviets faltered. Their 2 chief designers, the fierce competitors Korolev and Chilome, couldn't agree on a design.
Sometimes in our country it was more competition even than in United States. And I joke at that time that both these chief designers, Korolev and Chilome, they're thinking that better it will be Americans first than my competitor here.
The Soviets never did choose a successful design. The race was never even close. We went to the moon for one simple reason: Cold War competition. And yet, we almost went for a very different reason: cooperation. For known to only a few, a week before he was assassinated, John Kennedy offered the Soviets a joint mission to the moon.
My father, when we walk around our house, told President once more, arose this question. And I think we have accepted this invitation. And I was opposed this. I told it's our secrets. Americans will know it. And he laughed at me, maybe not laughed, smiled. He told Americans smart enough to design everything what we have. But if we'll join this, we will save a lot of money. But next week, it was no president who offered this.
By 1965, and certainly by 1968, it was clear that there was no race. The moon race had disappeared. But the American people seemed to be absolutely dedicated to us, to continuing the effort to ensure that human beings did go to the moon and that they were Americans.
With the political challenge gone, we needed a new reason to go to the moon.
Well,
Science.
In my left hand, I have a feather. In my right hand, a hammer.
It was symbolized by repeating Galileo's famous experiment, dropping two objects of different mass.
How about that?
And yet the astronauts were fighter pilots, not scientists, all except for one.
It came down to the last mission, the selection of a crew for the last mission, Apollo 17. The pressure was on to put a scientist on the moon. And so the only geologist, and therefore the only really legitimate scientist that might be qualified to study the moon was selected, and that was me. I just happened to be in the right place at the right time. Well, the first thing that I felt when I stepped on the moon was a feeling that I was going to fall, and because I had stepped on a sloping rock that my foot slipped out from under me.
Oh, dadgummit.
After the scientist got his footing, he began to experiment. Jack Schmitt set off explosions to study the moon's core. He placed a seismic instrument which actually detected moonquakes. And of course, he collected rocks, over 100 pounds. Without wind or water to cause erosion, moon rocks are far better preserved than Earth rocks. These ancient rocks, many over 4 billion years old, are a window to our past.
Very cohesive.
Most important thing we learned from the moon rocks as a group was about the history of our own Earth. The early history of the Earth is exposed and recorded in the rocks of the moon. We would not have had access to that early history had not we gone to the moon.
Still studied today, the lunar samples are a lasting legacy of Apollo.
Moon rocks are very secure. They live in this vault. They are protected by all sorts of sensors from fire, flood, intrusion. They're absolutely beautiful. The crystals in them just sparkle. You can see where every few million years a meteorite may have knocked a small pit in the surface. I guess it makes me feel very humble.
Back on Earth, the lunar samples revealed a surprise. The moon was once intensely hot.
They're extremely dry, they have no water, and they don't have a number of the elements that tend to boil at relatively low temperatures. These rocks must have seen a time of very, very intense heating early in their history.
So hot was the moon that scientists now conclude its entire surface was once an ocean of lava. What made the moon molten? Did these rocks hold the key to the most fundamental scientific question of Apollo? Where did the moon come from?
I think the formation of the moon is important because it's one of these questions that kids have been asking their parents for 10,000 years. You know, where did the moon come from? It's kind of one of the basic questions. Where did the Earth come from?
Bill Hartman is a planetary scientist and an artist. He's painting a collision between a giant asteroid and the Earth. It's at the heart of his theory for the origin of the moon.
The short description of how the moon formed is that a very large object, something like the size of Mars, which was another planetary body, forming at the same time, crashed into the Earth, blew a lot of material out of the Earth, and that material went into orbit and accumulated into the moon.
The giant impact theory is based on Apollo data. The fiery event even explains the intense heat recorded in the moon rocks. Yet the theory was initially rejected. Only a few years ago, we couldn't imagine an asteroid hitting the Earth.
Before we began to develop these ideas, there was a feeling that, it's like Shakespeare said, the Earth's a stage. I mean, there was this unconscious feeling that the Earth was a stable body. It's been this way forever. It just sits there. And that's completely wrong now, we know.
Thanks to studying the moon, we now know we're a target for asteroids. The origin theory is now considered the crowning scientific achievement of Apollo. And yet, even though the moon had more to teach us, we abandoned it. Without a clear political goal, science simply wasn't enough to motivate the public and justify the huge expense. After 25 years, there may now be a new reason to return, not for science, but for entertainment.
The problem with Apollo was its great success. We beat the Soviet Union to the moon, and that was that. And what we need now is something that actually delivers something to millions of people instead of a handful of astronauts. What would you rather do? Pay to build a roller coaster and watch government employees on the roller coaster, or go on the roller coaster yourself? The idea of LunaCorp is to try to create a project where lots and lots of people can take part in space exploration. We're going to do that with telepresence.
In 2000, LunaCorp will put a real rover on the moon and let you drive it remotely from a theme park here on Earth. You'll see what the rover sees and feel every bump on the way, but you'll have to pay for the experience, for this will be a commercial venture. They'll even have corporate sponsors who can buy ads or even buy the rights for the first drive.
Well, companies can be involved by having promotions and contests. And we hope that corporations can look at space as a way that they can do something positive and also sell their products. So if there are any company presidents out there, I'd like them to phone us up at 1-800-GO-SPACE and see if we can strike a deal.
3, 2, 1,
There are some folks who don't want the moon touched ever again. They want it to be a shrine. But basically, it has all the all the romance of an abandoned cement plant. There's no reason why you should treat it like a shrine. We're going to be very careful at Apollo 11. We're not going to roll over any footprints. But for the rest of the moon, let's make use of it. It can be a stepping stone to the rest of the solar system.
Going to the moon was a defining point in our nation's history and one of our greatest technical achievements. Now, the only way to go back to the moon may be to turn it into a theme park.
Is that ironic? I would say it is the way things are done. It is unfortunate that we did not go forward to fully utilize the investment that we made with Apollo, but that's now water under the bridge. The question is, what do we do next?
A meteorite found buried in the Antarctic ice for 13,000 years. Analysis shows gases trapped inside match the Martian atmosphere. Microscopic images seem to show 3.6 billion-year-old fossil bacteria. Does this rock hold the answer to the age-old question, is there life on Mars? Or is it one more in a long history of false alarms, like the 1976 Viking mission? With its sophisticated biology experiments, the Viking mission was designed to search for life. Though one experiment was designed not by a biologist, but an engineer, Gil Levin.
I was called downtown to NASA one morning by the officer in charge of the program. And he said, you just aren't properly credentialed. So that we suggest that we bring in someone else who is suitably credentialed. And I said, the heck you will. This is my experiment. What do I have to do to get credentialed? And they said, well, at least you have to get a PhD. I said, okay, I will do that.
Viking did launch with Levin's experiment, as well as one designed by eminent biologist Norm Horowitz.
Before we got to Mars, I was pretty sure we would not find life. I didn't see how there could be life on the surface without water.
And it was clear that there couldn't be liquid water on Mars. But I stayed with the, I had undertaken it, and I wasn't going to leave.
I'm sure everybody here remembers seeing, if they didn't see it when it first happened, later, that arm of the Viking lander go out and scoop up some soil and bring it back. They brought that soil back, and our experiment got a little tiny bit of it about that big, about a gram's worth.
They tested their sample by squirting it with radioactive nutrient. If there were organisms in the soil, they would ingest this nutrient and produce radioactive waste.
And immediately, we got a response. We were ecstatic. We couldn't believe it. It came in, I think, about 8 o'clock at night. We were at JPL, and everybody in the room was just rocketing around because we really thought it was a long shot that we'd find life on Mars. And here we have this data just pouring out at us.
It was very exciting when the Viking results started to come back. And it was amazing because we got positive results. In the case of my experiment, the results were very weak, but they were significant. They were significantly positive, just barely. But still, we didn't expect any positive results, and so it took quite a while to figure out, is this really life, or is it chemistry of some kind? And it took quite a while to do that.
Viking had discovered signs of life on Mars, but could there be a non-living explanation? To find out, chemist Jim Orenberg is cooking up some Martian soil.
The secret recipe is not so secret. We start off with this material called Wyoming bentonite. It's a very common clay. And to that we add an exchange resin. Then we add the ion of interest, ferrous chloride. And then after some steps of preparation and some air oxidation, we end up with this nice reddish-brown, iron-enriched clay. Well, there's one last ingredient, just a dash of salt, a very small dash of salt. But this is what we think is a very reasonable analog to the fine covering on the Martian surface.
With his Martian soil, Orenberg is repeating the Viking biology experiments.
The experiment that we're doing is one of the Viking biology experiments. It's called the gas exchange experiment. And what we're doing is we're measuring the amount of carbon dioxide that is given off in the area above the solid sample and the liquid.
Even though there are no organisms in his simulated soil, he gets the same positive results as Viking. It is now believed that the Martian soil contains not life, but a strong chemical, hydrogen peroxide bleach.
Turned out that the Martian surface material, the Martian soil, is very reactive chemically. And it was the soil itself that was reacting and not the organisms in it.
Gil Levin, though, still believes he detected life.
All the criteria that had been established for the detection of life were accomplished. And on Earth, no one would deny that we had detected living organisms in that soil.
I don't know of anyone who agrees with him on the Viking team or anywhere else.
We never had a true scientific debate before a neutral group of scientists to evaluate the data. I have fought for that for many years, and it has not come about.
I think the question of life on Mars is almost a matter of religion to some people. Some people will never give up the idea that there's life on Mars.
20 years after Viking, there are new converts to the Martian religion. In this Martian meteorite, NASA's Dave McKay thinks he has found evidence not of present life, but of ancient fossil life. And once again, the question arises, is this life or a non-living mimic?
These are some of the grains in the iron-rich zone of the carbonate, and some of them, in fact, might be microfossils.
Examining the Martian meteorite, McKay found these tiny rods that resemble fossil bacteria. They're only 1/1000th the width of a human hair. He took his top secret findings to Kathy Thomas Caperta.
I can keep a secret very well. We started working on this, Dave and Everett really began this project about 2.5 years ago. And at that time they said, we have some very preliminary evidence that hints at the possibility that we are finding some evidence for past life on Mars after looking at this one meteorite. And I sat there in disbelief. I could not believe that. As soon as I started seeing these magnetites and sulfides, I became sold.
Using the transmission electron microscope, Caperta found a mineral, magnetite, in a form usually produced by bacteria.
This is most likely a magnetite. The shapes are usually cuboid or teardrop, and those shapes are normally associated with magnetite that is produced from different bacteria, rather than magnetite that is produced inorganically.
She vividly remembers the discovery.
And it was about 6:30 at night. It was getting dark outside. And I walked outside and I thought, you know, there are no bands playing. There are no banners waving out here. I remember telling my husband, and he said, oh, that's just great. That's so nice. And I told my folks, and they were like, oh, well, honey, that's special.
But Dave McKay was more impressed. The magnetite data, the photographs, as well as the finding of an organic molecule usually produced by dying cells, all pointed to fossil life.
But by the time you put all this together, it's not any one line of evidence. It's all of them, I think, that contribute toward our interpretation that these are biology, Mars biology at work here.
Pictures don't lie, and that's the important thing to keep in mind, but our interpretation of them may be in error.
Fossil expert Jack Farmer is skeptical. The bacteria are 100 times smaller than any microfossils seen on Earth. And though they do look like bacteria, no DNA or cell walls have been found. Farmer thinks the bacteria may actually be mineral mimics called pseudofossils.
Simple structures, particularly at this scale of observation where you're looking at nanometer-sized things, it's very easy to go wrong because things can happen, just inorganic processes will create structures that look very similar to biological structures. So what we need to do is gather more evidence, and what we really need to do is bring more rocks back from Mars. We let sort of gravity bring this one to us, but I think this time we're going to have to go to Mars and bring back exactly the right kinds of samples to evaluate the question.
And yet, where would we even begin to look for fossils? Ancient Mars was once a warmer and wetter planet. Jack Farmer has found a strange site in California that he thinks resembles ancient Mars. It's called Mono Lake.
Mono Lake is a terminal lake. That means water flows in, but it only leaves by evaporation. Well, we know from the Viking images taken from orbit that there are lots of large terminal lake basins similar to what we have here in the ancient terrains of Mars.
Because water can't flow out, Mono Lake has developed a unique chemistry that produces limestone structures called tufa towers.
Well, what we see here are tufa towers. This is what Mono Lake is famous for. Here you can see a place where the submerged part of the tufa is visible, and it has this greenish cast. That green color are the microbial communities that are living on the surface of the tufa. And these organisms are encrusting that surface, and then as the tufa forms, continues to grow, precipitate out of water, the microbes get entrapped in the tufa basically and buried, fossilized if you will.
Because the tufa towers capture microorganisms, Mono Lake is virtually a fossil factory. That makes terminal lakes and limestone tufa towers prime targets for finding fossils on Mars.
What I'm doing here is I'm obtaining a spectrum of the light coming off the surface of this tufa tower This spectrum is being acquired in the near infrared. That is the kind of range of wavelengths that we'll be obtaining from the orbiter that's going to be launched to Mars this year.
An orbiter is scheduled to scan the Martian surface with an infrared detector. If its data matches Farmer's and turns up tufa material, we'll know where to look for fossils. But then the question will be how to look. The answer is rovers.
So using rovers, we need to get really close-up looks at candidate rocks which look like the right kind of rocks. The kinds of rocks that on Earth we would say those rocks would probably contain fossils. Then we need to actually get samples of those rocks and bring them back.
Soon we'll have our first chance ever to look for a fossil on Mars. The mission is called Pathfinder.
The Pathfinder probe will deliver the lander to the surface. First, coming into the atmosphere on an aeroshell, the lander will drop off onto the surface and land on a cluster of airbags. The lander will bounce around on these airbags and eventually settle down. The airbags will be deflated, and this tetrahedral-shaped lander will open up, and out will come rolling a little micro rover.
It will be the first time that we've had any mobility on the surface of Mars. The rover itself, you know, being pretty small and low to the ground, it will also have cameras on board, but it will be seeing things from kind of like, you know, the dog's eye view.
The landing site for the Pathfinder mission is a site that has a lot of interest for exopaleontology. Our top recommendation was, in fact, the site that was chosen. It was a good site for lots of reasons, but from the standpoint of sort of a first attempt to look for aqueous mineral deposits and the rock types that we think are important maybe to capture a fossil record, it's a good place to go.
Pathfinder will be followed by ever more sophisticated rovers. It is hoped that before the year 2005, missions will even be able to return Martian samples to Earth. But finding fossils on Mars may prove to be one of the most difficult space challenges ever undertaken.
It's not going to be easy. It's a needle in a haystack. I guarantee you would not see it. It takes a trained scientist to even know that they're standing on fossil life. My personal view is that we won't really know whether there's life on Mars, either existing life or ancient life, until we have people on the surface of Mars.
For now, the question of life on Mars remains unresolved. All we have is one single tantalizing meteorite. But it's a rock that raises the most profound questions. Are we alone? Are we related? Are we Martians?
You can certainly imagine that in some cases, live bacteria could come from Mars to the Earth and grow here. And one of our co-authors, Dick Zare, likes to say that we might all be Martians. That is, we might have evolved from some early Mars life that came to Earth in a meteorite billions of years ago.